Hey, good morning, students, or I guess whatever time it is where you're watching the lesson. Welcome to Geometry A. This is Mrs. Brunk. We are going to be beginning a module all about quadrilaterals. So we've spent a good portion of our time in Geometry A studying triangles. And so it's time to move on to the next step, which is looking at one more side in the figure, and that's a quadrilateral. So instead of three-sided figures, we're going to be focusing on the four-sided figures. And I mean, when you hear the word quadrilateral, you may think of some really common ones that you've studied, like the square and the rectangle. But we're going to explore some of the lesser known ones, like the parallelogram, the trapezoid, the rhombus, and the kite, along with our familiar rectangle and square. Today's lesson, though, will focus on properties of parallelograms. So we're going to focus on parallelograms to begin with, and our learning goal is to be able to use the properties of a parallelogram to find measurements. So first of all, a quadrilateral. So that quad means four. So a quadrilateral is a parallelogram with four sides. Specifically, we're going to focus on that the parallelogram today, which, indicated by its name, is a quadrilateral with two pair of parallel sides. So we have two pair of sides that are parallel to each other, and that marks a quadrilateral called the parallelogram. So this will be quite a short lesson. All we are going to be doing is just looking at the properties that make something a parallelogram and then applying it to solve some problems. So there are three big theorems that we're going to focus on, or parts, I guess, to the same theorem. These are all part of the same theorem called the properties of a parallelogram theorem. And a segment that connects two non-consecutive vertices of a parallelogram is called the diagonal. And so some of these deal with this term, the diagonal. So up front, a diagonal is something that connects opposite vertices. So for instance, in this drawing right here, this right here would be a diagonal. Okay. So actually, I'm sorry, there's four parts to this properties of a parallelogram theorem. And the first one, number one, is if a quadrilateral is a parallelogram, so if it's a parallelogram, then its opposite sides are congruent. So what that would look like in this diagram would be opposite sides would be marked equal. They're congruent, right? So not only are the opposite sides parallel, because that's kind of a given in a parallelogram. If we have a parallelogram, so maybe to start, we should draw a parallelogram that marks the definition on it, and that is, I didn't do a very good parallelogram there. Let's see if I can do a better job. So on a parallelogram, to show that opposite sides were parallel, we could mark those arrows that show parallel. So your opposite sides would be parallel. That's by definition. But by the properties of a parallelogram theorem, number one, the opposite sides are congruent. So not only are they parallel, but they're also the same length. And two, opposite angles are congruent. So this angle right here would be congruent to the one opposite it, and over here, this one would be congruent opposite it. So your two pair of opposite angles are always the same measure. An additional thing, which doesn't really look like it's listed as a property, but it is, it's consecutive angles add up to 180. Now what that means is, and we'll mark that on this last picture, is that these angles that are next to each other add up to 180 degrees. And these angles that are next to each other would add up to 180 degrees, and so on, all the way around the figure. So consecutive means next to. So angles that are next to each other are supplementary or add up to 180 degrees. So like for instance, if we knew that this angle right here was, say, 70, well then the one next to it would be 110 because they have to add up to 180 degrees if they're next to each other. And then the one opposite, the 110, would also have to be 110 because their opposite angles are equal, but additionally it's next to an angle that's 70, so they have to be supplementary. So that's actually ends up being a very important property, so for some reason not included as an official box in our lesson, but nonetheless very important. So that's the third property of a parallelogram. And the fourth one involves the diagonal. So we just defined what a diagonal is. And in fact, in a parallelogram, the diagonals bisect each other. So what does that mean? So that means if I were to draw on these diagonals right here, then they would actually bisect each other, meaning that they cut each other into equal parts. So like those two would be equal, these two would be equal. So in other words, they meet at their midpoint. So that point right in the middle is the midpoint of both of those diagonals. So keeping these properties in mind, we're going to see if we can answer some questions about these parallelograms. So find the measurement indicated from each parallelogram. Okay, so in example A, they want me to find this angle. So there's a question mark there. So remember, we just learned that opposite angles in a parallelogram are equal. So that means this angle over here must be 82 degrees. So it's the same as the one across from it, 82 degrees. And B, they want you to find this angle right here. So they want this one. Well, this angle is actually next to the angle that's 108 degrees. So we said that the angles that are next to each other must add up to 180 degrees together, which means that this angle right here has to be 72, because 72 degrees and 108 degrees makes 180. In C, they want us to find this side here. So we are given this side across from it that's 16, which means this one must also be 16. And in D, they're asking you to find this angle right here, which is, again, another angle that's consecutive with an angle that's given. So that means these have to add up to 180 degrees, meaning that this angle has to be 180 minus 95, which is 85 degrees. So that's not so bad. That's just applying the properties. We know that opposite sides in parallelograms are equal. We know that opposite angles are equal. We know that consecutive angles add up to 180 degrees. But we also know that the diagonals bisect each other. So moving on, start to, of course, get a little more complicated and throw some variables in there. So this time we are looking at finding some values of variables. So they want us to find, and some measurements here. So it wants us to find each measure that's labeled. I'm assuming that's what it means, each measure that's labeled. So let's first focus on these two angles that are labeled. And I can tell these are labeling angles if it's ever in question, because they'll put the little degree symbol on there. So I've got one that's labeling angle B and one that's labeling angle D, and I know that those are opposite angles in a parallelogram, so I know that they're supposed to be congruent. So I could write an equation that says that they're equal by saying that 6x plus 5 is equal to 8y, I'm sorry, not 6x, but 6y plus 5 equals 8y minus 17. And if I solve this equation, it'll tell me the value of y that will make those angles equal in measure. So first thing I'm going to do is I'm going to subtract 6y to bring the y's on the same side and simplify, which makes 5 equals 2y minus 17. Now I've got to bring that minus 17 to the other side, so I'm going to add the opposite. And that leaves me with 22 on the left-hand side. 5 and 17 is 22, equals 2y. If I divide both sides by 2, I get y is 11. Now, I could take that 11, I could substitute back in and find the measure of these two angles. So angle B would be 6 times 11, which is 66 plus 5, and that's 71 degrees. And then when I plug it in down into D, 8 times 11 is 88 minus 17 is 71 degrees. So we know that angle B and D are 71 degrees. Now, if I wanted to, I could find angle A and C as well now because of the fact that because these angles next to each other have to add up to 180, I know that this angle right here would have to be the rest of 180, which is 109. So I could actually find all of these measurements just by knowing what y is, okay, and knowing these relationships for angles within a parallelogram. So now what about the other variable x? So this time I've got these two parts labeled with x, and I know that those are opposite sides in a parallelogram, which, again, I just learned must be equal. So I could just say that 5x plus 19 is equal to 7x. And I could solve that equation to find the value of x and then the opposite sides. So solving, I'm going to get the variables on the same side, so I'm going to subtract 5x from both sides. Nine and a half. And so I know now that x is 9.5, so that would allow me then to substitute back in and find the lengths of these sides. So this side would be 7 times 9.5, which is 66.5. So we know that that side's 66.5 units long. And then 5 times 9.5 plus 19 is 66.5 as well, which really just confirms that relationship that we know has to be true. The opposite sides have to be equal. So there we can see they're equal, 66.5 each. Okay, so let's take a look at this next example. So we're told that this is a parallelogram. And so let's take a look. We're trying to find value of two variables, both x and z. So let's start off with what I think looks like the easiest one. So we've got these two sides that are labeled with the variable z, and I know that in a parallelogram, the opposite sides are equal. So I know that for a fact from the properties of a parallelogram theorem. So if I wanted to find out what the length of QR is, which is what the first question asks, I'm just going to find the value of z by saying 2z plus 4 is equal to 3z minus 4. So to solve, I'm going to just get variables on one side by subtracting 2z, and that makes 4 equal to z minus 4. And then I'm going to add 4 to both sides to solve for z, and that tells me that z must be 8, which now I can take that and substitute that back in over here on my drawing, and I can find out the length of QR, which is 3 times 8, which is 24, minus 4, which is 20, which means this side is also 20. Now taking a look at the other parts that are labeled in our drawing that have the variable x, we have this and this. Well, we also learned by the properties of a parallelogram that diagonals bisect each other. So in other words, T is the midpoint of both of those segments, PR and SQ. And so we know that if T is the midpoint of PR, that those two segments, PT and TR, must be equal. So we can just say that x plus 9, which represents PT, must be equal to 4x minus 6, which represents TR. And now all we have to do is solve to find out what the value of variable x is, and we can substitute back in and find PR, which is the whole length there. So subtracting x then gives us 9 is equal to 3x minus 6. If we add 6 to both sides, add 6 here, add 6 here, we end up with 15 equals 3x, and that means that x must be 5. So taking that and substituting back in, we can find the length of PR, because PT would be equal to 5 plus 9, which is 14, and TR would be equal to 4 times 5, which is 20, minus 6, which is 14, and that whole length then, which is PR, would be 14 and 14, and that's 28. So there's our value of PR, and then our lengths that we found of QR right here. So those are the two things they asked us to find, and we were able to do that using the properties of a parallelogram. And now to our final example. So again, we're told this is a parallelogram. So all these things we know are true. We know opposite sides are equal. We know opposite angles are equal, things like that. So starting off, we have two variables we have to find. And the first one that kind of just jumps out at me is I know that the opposite sides are equal. So I know that 2x must be equal to x plus 3. Oops, must be equal to x plus 3. And so that's a really easy equation to solve. All I have to do is subtract x from both sides, and that means that x has got to be 3. So if I subtract x from both sides, I end up with x equals 3. And then if I wanted to find these lengths, RS, so RS is down here, I just have to take 3 and add 3. So x is 3, so that's 3 plus 3, which is 6. Now in order to find n, which is labeled here and here, now these angles are consecutive, so they have to add up to 180 degrees. So my equation will say just that 10n, which represents angle S, plus 8n, which represents angle R, has to add up to 180. So that means 18n, when I combine those like terms, equals 180, and that means n must be 10. So now I can find those angles just by substituting in. And so since n is 10, angle S is 10 times 10, which is 100 degrees. And then angle R is 10 times 8, which is 80. So using these four properties of parallelograms, the fact that opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, those properties, along with the fact that opposite sides in a parallelogram are always parallel, we can solve lots of problems. Thanks for coming to class.